Hello everybody. Uh, Welcome back to the channel. Once more, it has been a while, but let's get to it. Today I want to program some MQTT messaging from ESP32 C3 board. But before, I'd like you to introduce the two of the new boards I'm using right now. On the left there is the Lily Go, the T8, which is pretty nice, and one of the reasons I bought both of these is that they have a USB-C connector, and it's just so much better than a micro USB. It's not that I need more speed or something like that, but it's just more robust. So many times I've had trouble with one of the controllers, and it turned out that it could be resolved by jiggling the micro port a little bit, and then the micro USB port a little bit, and that solved it. So it's really nice that the USB-C are so much more robust. On the right there is the other one that's a wave share, and I really like that because it's so small for obvious reasons. It is a really nice board. It's yeah, it doesn't lack anything. I mean, it has less pins, but if you look carefully on the one on the left, on the T8, there's a lot of the pins. They're all marked with NC. NC means not connected. So in the end, I'm not exactly sure, but they're pretty much the same in terms of pin count. So I do think that the one on the left has a battery circuit, so that might mean it be different to someone. And there's a LED on the wave share as well, but that doesn't have the traditional RGB controls, so it's a little bit more tricky to get to work, but I'll get to that. It's but yeah, I just wanted to show those. So let's get to it. First, let's switch. MQTT is a messaging protocol which is pretty popular in the IoT space. I don't think it's used much outside that space actually. And the property of MQTT, it's about messaging. So you send it from one unit to the other. Not so much like HTTP, where you have clearly a client and a server. And we have done both. From the microcontroller, we ran the server on the microcontroller with PicoServe, and we ran the HTTP client as well with Recules, which worked out all right. But MQTT is more about sending messages. If you have two devices and you want to send a message from one to another. What makes it kind of interesting is that MQTT communication is typically not direct. You don't connect from one device to the other. Like we did, for example, with our remote control car. We just used ESP where you just send a message to another device, or like a broadcast to all the devices in range. MQTT is different, that you use a broker. There's a well-known server somewhere, and you send that message and you give it the topic. And you can also register to a topic, and then you receive all the messages. So that's how you address. You send the message to a topic, and somebody might or might not be listening to that topic. But that's not something you directly care about. So you just deliver the message, and if the MQTT protocol says the message has been delivered, then that's where your responsibility stops. So it's generally a TCP based protocol. So there are public brokers. So like this one from Eclipse. It is on port 1883 without encryption. There's also an 8883 that's with encryption. And there's also a WebSocket variant, but we don't really have need to that. Here's some description of the Waveshare Mini. And as you can see, there are still quite a bunch of pins that you can use, so it's not as cramped as you would think. And here's the LilyGo, which is a nice board. But again, yeah, given that it's missing so many pins, I was a little bit disappointed, because on the remote control car we were kind of starting to run out of pins. In any case, so let's get to Rust and let's create some MQTT connectivity from scratch. I will try to build it up a bit more step by step. The ones before I was spending, I think, too much time just copying and pasting, just showing code. I'll try to do it all from scratch right now. So let's go. Let's start by ESP template, as we always do. So that creates a functional microcontroller program. So let's see. First, let me connect the microcontroller before I forget. So let's call this ESP32 MQTT. We have the C3 chip. Is the font size good? Something like that. Let's do the advanced things. Yes, I would like Wi-Fi. Alloc, yes. Dev containers, no. Walkway, no. CI, doesn't really matter. Logging, yes. So let's open VS Code. So I actually had the last few weeks, I had issues with the nightly Rust chain. It didn't work with anything like anything of Embassy and the async runtimes. Not exactly sure what went wrong, but I used the ESP toolchain, which didn't have that problem. You can install that with ESP up. You need those if you want to use the extensor architectures, but I don't really use those. But in this case, it didn't really matter. But since a few days, the nightly is working again, so I can just leave it here. So let's see if we run this on release. Let's see if cd ESP32 MQTT. Let's see if we are starting from a good point, right? We want to know that it works now. Choose a tag. Alright, so that looks fine, right? It's running, it's saying a loop all over and over again. And if we look at our code, it just has a main. It does do some Wi-Fi initialization. We'll need to do quite a bit more. But then we loop, and then we wait for half a second. But at least this works. Perfect. So we're gonna need quite a bunch of dependencies. And let's have a look. So first we need to add Embassy. But before we can actually add Embassy, we need to add some let me check. ESP HAL. We need to add some features to the HAL, because the hardware abstraction layer. So right now it's only using this one. So let's do a cargo add ESP HAL, and then it says that it has these, but there are 49 deactivated features. It's kind of unfortunate, I think, that it doesn't say which deactivated features there are. So you can say features and you say something ridiculous, and then it will say which features exist, which is usually what I need to know. So we need to have a bunch of Embassy stuff, and Not sure if it's all of it, but quite a bit. So we need embassy. So that's the runtime. Embassy executor. I don't think we need to interrupt, but maybe I'll be proven wrong. Embassy futures. No, I'm running out of the screen. Futures. Embassy integrated timers. I need that. I need embassy sync. And HAL async as well, I suppose. I think a lot of them depend on each other, so you don't really need all of them. But let's see where we end up. Now we have added a bunch of the features of the hardware abstraction layer, but that doesn't actually add the dependency itself. So we need, for example, embassy executor itself. Let me have a look, blah, to see what's there. And we need the executor thread, I think. And I think the nightly as well. Okay, we need to add embassy time. Alright, so we have a bunch of things. Let's see how far we get with this. So we are looking for, so here we initialize this timer, we initialize the Wi-Fi, but let's first convert this loop, which is a busy loop. So this will just pause the controller for half a second and then print loop, but it can't do anything else because it's like a single threaded system. Let's replace that with asynchronous system. So where to begin? First of all, we want to make an executor. So that's a component of embassy. It's kind of the component of embassy. So let's say let executor is now executor dot new. Let's see what we need for that. So that's present there. What is it? Complaining. I don't think it's the right one. Let's try that import again. I think we need another. Let me check. Maybe we're missing one from the embassy HAL. So, because it needs to be there. So we added, well, most of them. Oh wait, this was not correct. Forgot the comma here. So maybe this makes a difference, and the other one I wasn't sure about. That was this one, the executor. Let's say what it was missing. I think it should be alright. So why can't I find the proper executor? I'm honestly not totally sure why that is. Let me figure that one out. I really think we're having the wrong executor. Is this, maybe I have to add the, is the RISC-V here as well? Oh, it was already enabled. That's not it. Let's add async. I didn't add that one, right? Let's see what that does. Because I'm pretty sure it's not the raw executor, but I forgot where it is. And maybe the executor interrupt. Well, let's try. Embassy executor thread, the nightly. Does that also needs the executor interrupt? I'm a little bit at a loss with this one. Oh wait, this one looks like it didn't add anything. Did this one error out? Embassy futures, I misspelled something. That's dumb. So now I probably added a bunch of stuff that we don't need, but oh well. Yeah, now it has stuff. Let's see what this does. Did I import it again? Yeah, this is not the right one. Yeah, here it is. This is the one I had in mind. So it's on the ESP the executor, and that should do the trick. And then the next step we gonna do is the executor, and we can do why can't I spawn something? Let me check. Oh, it's called run. Okay. So this pattern we have seen before. We have seen it pretty much every time we use an executor. We can spawn a task, so we can use a spawner. We say spawn, and then we create a task. Task is an async function. Let's call it print stuff. Let's see if this is all. Maybe make it a little bigger. That creates a loop, and in that loop we say let's say print line hello. Then it's really important to always do something asynchronous in any loop, because otherwise it will never give up control and give the runtime an opportunity to do anything else. So we say after, let's do it a little bit slower, after 1 second, and then also not forget to await it, and that's enough for this one. We need to annotate the function with a task. Embassy task, and then here we can run print. And then we need to unwrap the whole thing. Okay, then we can remove this loop, and let's see where we're at. Let's run this thing. Okay. So somehow there has been a conflict. So that's the result of us adding too much stuff. The embassy's time systic. I don't think I need that there. This one I definitely need for Wi-Fi for embassy. So let's try to figure this one out. Just copy this one and try to figure out why we have this thing, because I'm pretty sure I didn't. It's not here. That's awkward. Let's see what happened here. I think I should remove the interrupt. I didn't put it in at first. Let's see what this does. So there are different runtime methods, and you only need one. Still something with time. Integrated timers. Embassy time. That seems okay. This one I wasn't too sure about. What are we using in the executor? So somehow this one is selected, and I think it must be one of the features I have activated in the HAL. And they seem all pretty innocent. Which is the one that shouldn't be there? Oh, you can see what happens if we remove this one. Or is he saying that I need to add one? Let's add this one. Yeah, I misinterpreted that error messages. Okay, now we are in a bit more known waters. So it compiled a bit farther now. So we'll need to add some feature flags. And like I noticed, like Rust developers in more the standard settings are wary of those, but in embedded, everybody just does that. This needs to be mutable. Let's see. Does not live long enough. Yeah, that is true. So, well, it's not totally true in the sense that it says this doesn't live long enough, as this method call never returns. You could argue that it does live long enough because it never goes out of scope, but the compiler doesn't really see it like that. So what we can do for that, we can do a box leak. That's basically you're saying we're gonna make a reference and we're never ever gonna let go. And oh yeah, and in that box leak we need to add a box. That's simply how it works. So like this, then it doesn't need to be mutable. And this thing, if I show the types, you see it's a mute executor, so it will only have a reference, but one that lives forever. Okay, so now this seems to have resolved. Let's see. Ooh. We have a linking problem. Embassy schedule wake. So now I'm gonna start to think about that I removed stuff I shouldn't have removed. So let me re-add that that interrupt one. What was it? Let me go back. Embassy executor interrupt. Bit wary of executing that command line now, because who knows what it might revert. That didn't work. Is it the same? It is some kind of combination of features we need to enable. Let's do a quick Google. Let's make sure we quote it. That is not super helpful. This is a little bit puzzling. We added the time. We added that. Maybe it is more in one of the other. Did we add integrated timers? No. Maybe it's here. Let's have a look. Cargo add the embassy executor features. Blah. Let's see what exists. So we did have the executor thread, the nightly. Integrated timers. Yes, so that was it. I needed to add the integrated timers to the executor. Now it asks for a JTAG, where it's connected. Now it's uploading, and it says hello once. Did I forget to make it a loop? No, I think I forgot to do something else. And that's because I didn't initialize the runtime. Because I can just spawn something and that works a little bit, but the moment it steps out, it never steps back. So that's why I get one hello and that's it. So basically the async part isn't really working. So we have the executor. What we need to do is to initialize embassy. I don't think the order matters much. Init. And what was I think so. What do we need to pass it? Clocks and a timer group. So here we see the clocks reference and the timer group. Timer group we need to make, the clocks we already have. So that's created by the template. So clocks. And let's create a timer group. Let timer group something like timer group new. That's a peripheral. TIMG 0 or 1. I think it was 0. There's one that's reserved for Wi-Fi, I think, but I honestly don't know exactly. So now we have a timer group. Pass it to the initialized embassy, and then we run it. Yeah, let's see. Uploads are nice and quick as well. Look, so now we have a properly running async runtime, because yeah, now it will notice when 1 second has passed and yields control back to the controller. Okay, what's next? It's already going on for a while, but let's at least get the Wi-Fi working. What do we have in terms of networking? So we have Wi-Fi, the ESP32 one. That seems pretty good. The SmolTcp. That's the async interfaces to the network stack in a sense. I have a feeling we're missing something, but we'll find out. So we need to create a network stack. So we have initialized the Wi-Fi. That's all well and good, but then we need to create a stack, and that's a thing that will. Well, let's see how far we get. Let stack equals stack. Oh no, capitalize stack. New. Do we have this thing? We don't. So I think we need to add embassy net for that, because I don't think we added that one. That was my feeling. Okay, so what does this mean? It needs a bunch of features. We definitely need DHCP, because we're going to connect to access point that will give us IP. DNS for good measure. I think you need medium Ethernet, or at least you used to. Maybe it's not the case anymore, I'm not sure. And let's say TCP, and for DNS we need UDP as well. So something like that. So let's see. Now we have the stack, and what does it need? A bunch of things. I just opened the stack source, a config, stack resource, and a random seed, and a device. Okay, that's quite some things to do. First of all, we have this init thing. It's underscored, so let's remove that underscore because we're actually gonna need it. And let's split that up. So first of all, let's take the create a new Wi-Fi device. That's something like new with mode, indeed. We need the init, pass that in. And we need the device. That's I suppose also a peripheral one. And the mode, it's with something like SDA mode Wi-Fi. Yeah, this one. What is that? And there was something else I needed. I needed did I need anything else? Let's see. I'm not sure what this is. I'm calling it thing. I asked the type. it's a result with a tuple of a Wi-Fi device and something else. Let's deconstruct that. So let's first unwrap it. So it's no longer a result. And then we deconstruct it, device and a thing. Couldn't tell. It's a Wi-Fi controller, I think. Yeah. Let's call it controller. So now we have these two things, and the first one is the device we can add here. The second thing we need, because now it's missing the config, the resource and the seed. Okay, so config is DHCP config. Let DHCP config is config. There's so many. I think it's EmbassyNet. And I think we can just use a default here. All right. So let's pass this in. We need to create resources and we need to have a random seed. So resources, let stack resources new. So we create a resource object, and that's once what we are supplying here is the resource for a connection. And because it is capable of running in no alloc mode, we are not right now. I'm just allocating stuff left, right, and center. But we need to say how many connections we want to be capable of opening at the same time. So that's why we need to give it a constant. So and that's that constant you see here. So that would be something like 5. So now we have that data structure that will hold memory for 5 stacks. So we add that here. I think we just passed the whole thing. And the final was a seed. It's some random number. Something like that. Did I mess it up here and there? Could be. This is the device. I'm pretty sure that's correct. Config. What's the real error message? But it is about the first one, right? The device that I deconstructed at the beginning. Yeah. I'm not sure. Maybe we'll need to box leak that one as well. Use mode. This is a Wi-Fi device, static STA device. That is weird. That is really weird. It seems to compile reasonably well, but oh, I didn't. I should get better at reading stuff. It's complaining about stack resources, right here. So it wants a mutable pointer, not the stack resource itself. So we need to do the same trick again with the box leaking. So we say box leak, and in that we do a box new, and we put this thing in, and we close it. So then we create a mutable thing. It did solve that problem, but the other one remains. If we do this, does that do anything? Let's debug that part. So, because I have the feeling this, I always saw this as a separate one. Maybe just a Wi-Fi, that should work. Maybe it is something else. Maybe we're missing a trait, or at least using a trait here, because I have the feeling that we need something more. Because there's it's referring to a driver. And that's an embassy net. So that should be there. That's not a problem. What else do we need? Pretty sure it's something like that. Because we have the small TCP, do we have the embedded network of exception layers? I don't see those. Embedded network extraction layers. That did exactly nothing. Let's see, is there anything else that seems off? Maybe there's something missing here. DNS medium Ethernet. Oh wait, I think ESP Wi-Fi needs more. It doesn't natively come with the interfaces for Embassy, I think. So let's do that. What is disabled? Yeah, it's Embassy Net. And let's add async for good measure as well. I'm not sure we need it. So I think that will make a difference. Yeah. So that's again the complexity of working without an operating system. You need to align everything exactly, and if not, it will just simply refuse to do anything. So now we have a stack that seems to be pretty happy, which we could add to a task. So right now we only have this one. We could give it access to a stack, but there's not much point because yeah, it's not doing anything with Wi-Fi. But make no mistake, we're not there yet, because this is, now we have a stack, but it's not activated. So imagine that if you are connecting to Wi-Fi, you need stuff, right? You need to know where to connect, how to connect, what kind of security settings. So that's something that needs doing. And is that something you do once? What do you do when you lose your connection? There are a bunch of it's just a bunch of work to do. So I tend to do that in a separate file, and yeah, if you have seen some of the previous iterations where I used Wi-Fi, I did have the I did just copy and paste it all the time, because it's always the same pretty much. It's not very dynamic. So but I do think it's good to have a mental awareness of how that works. So let's create a task. Let's create two tasks, because there are two fundamental things we need to do. The first thing is that we need to connect. So async function connect, and that will specifically initialize the controller. It's mutable, I suppose. And this Wi-Fi controller, I think. I guess. Not sure if I need a reference or not. What's the problem? It needs a lifetime, so that's probably static in these settings. Okay, so what we want to do is to create a Wi-Fi connection and keep it, right? So if it doesn't work, then yeah, reconnect. So we have a big loop, and then we need to check the Wi-Fi state, and if it's not connected, we connect, and if it is connected, we just back down for a while and then we check again just to be sure. So we do get Wi-Fi state. Here we go. What does that take? Okay, so we can match on that. And this is all the status it could have. So we are kind of only interested in when it's connected, because then we need to do something special, right? So let me show you. So we have a connected, and then we are gonna wait until it disconnects. So this task will always stay in this state, and then it will loop back and reconnect. Okay, so what do we do? Controller, wait for reconnect. So Wi-Fi event. Some kind of disconnect. So there are also a set of functions that apply when we are in access point mode, so that the controller becomes the access point. What's wrong here? It's a future. We need to await it, which kind of makes sense. And we need to make sure that if somehow it doesn't work, that we don't hammer the system. After need to import it, embassy timer, after seconds, I don't know, 1, and await. Okay. And then we just do some stuff. Let's create a configuration object. So we want to control it as an access point, not as an access point, I mean. So we say we create a client config. That's client this one, I think. What does it need? Yeah. So we need a SSID and a password, and the rest we can take from default. So let's create some constants. SSID. That's let's get that from an environment variable that's declared on my laptop. What's wrong here? I need to type. Okay. And the same for password. So that's those are just simple environment variables existing on my system that point to those. And the rest we can just take all from default. Why doesn't that work? Am I crazy, or is this not how this is supposed to work? I can remove those. Oh wait, we're still in the match, of course, so we just need to ignore all the other ones and then continue after the match. Let's see, what's this? Okay, so that's a different data type. This is a heapless string, and I have a regular string. So heapless strings are designed for non-alloc, but we don't really need that. Can we do this? We're trying to. It seems to work a little bit. Yeah, here we go. So we need to take into consideration that it might not work, so we need to do try into and then we use those. Let's call this something, client config. Okay, what are we gonna do with that thing? Let's create this controller, set configuration, client config, and then I think, yeah, fair enough, a reference configuration. Let me check. So it wants a configuration. ESP Wi-Fi. Let's see. Oh, it's enumerator. Okay. So let's call that no, client. So we need to create a enumeration of configuration. It can be different kinds. It can also be an access point, or both even. And we wrap all that in there. We don't need this one. Just to refer to the thingy. It has a result. Unwrap. And then I guess we can start the Wi-Fi. Oh, wait, then unwrap, yeah. Okay, so yeah, we started the controller, and then I think we're not done. Yeah, then we need to connect. So then we await, and what do we get? That's a result. Let me think, do we need to do anything with this? Not really. Although being a bit more careful with error handling around these things is not a bad idea. Anyway, Okay, so that kind of sums up this task. We need to still annotate it as such. And then the second thing we need to do, which I mentioned, is the actual running the actual network stack, because that's something, yeah, you would not think about, but whenever something happens on the network, some package appears, it needs to be handled. So it needs to have a task, because otherwise where it's going to run, there is nothing magic here. So let's create another task. Let's call it run network. Run network, and make it a task. Oh, we need to make them public, by the way, because we need to run them from the main. This will need the stack we made. So we need to pass it to task, so we need to do the trick again that we do a box leak. So I'll just overwrite the variable box leak box new, and put in the stack. So that will consume the stack variable and replace it with the static mutable link to it. Did I make them public? Yeah. So spawner spawn. Was it connect, something like that? And we put in the controller. Where's our controller? And then we need to unwrap that thing. What did I call it? I did call it connect, I just need to import it. Okay. So that's the connection part, and let's also run the, what did we call it? Run network, and unwrap it. We need to give it a stack, because otherwise what's it gonna do? And let's check what the type exactly is. It's always a bit mysterious how to determine exactly what this type is. So it's a stack, that's mutable. No, I'm not sure it's mutable, but it's definitely static. Mutable stack. It said something about Wi-Fi device with lifetimes, it's probably static, and a device mode, so that was Wi-Fi SDA device. And do some magic importing. Yeah, so that yeah, run. That was it. Let's Now it's kind of hard to see what we're doing. So let's add a little bit of debugging here and there. So let's say info statement here. Let's say connected. And we don't need the AP started or the is invalid, I think, because we're not going to do that anyway. So let's just print something. I don't think we're going to need that one. It always messes up the indentation. We need to do default. Okay, we have something. Let's run it. Okay, we messed up a little bit. So line 29, we have been a little bit brash here and there. So we say start, and then we just assert that it worked, and that's maybe a little bit much. It might not work the first time, or it might need a moment. So let's not unwrap. Let's match on it, and then we can deal with both our possibilities. So in this case we can do info Wi-Fi up, and in this case let's say Wi-Fi down, and then we wait for a moment. After half a second we wait. So now we just try, and if this fails, then it will do the whole loop again. I think I have a bracket too much. Yeah, let's see what this does. It said it was down. Can we get any kind of information out of this? So we can maybe print that. Maybe it has a explanation. it doesn't really seem to want to work with us right now. So we are looking at the controller. We started, we awaited, and that seems to not fail because otherwise it would have panicked. We connect, and it keeps looping, or does it? I only see one iteration. That kind of surprises me. Because every time it passes this, it should either say Wi-Fi up or Wi-Fi down, one of the two. The fact that it's not saying anything, that's a little bit weird, because it also didn't say connected, so it didn't end up here. Did it say disconnected? Yeah, it did say that. So what would be here? Oh, nothing. Okay. Let's add some logging here and there. About to start. I'm just curious where it's hanging. And sometimes it's also just general wireless weirdness. It really should work. That's the controller right here. Can replug it. Let me check my Wi-Fi credentials real quick. It might be something really silly. I'll edit that out because that I don't want to share with the world. Okay, I figured it out. I thought it was maybe my router settings, then I concluded it wasn't. Then I added a lot of logging. I kind of made the whole state management a bit more careful, in the sense that I got a feeling it was hanging when I started, when it was maybe already started. I don't think it's really the case. In the end, it was my Wi-Fi settings were wrong, and it was from my holiday home. So I fixed that, and then it was all good. So now I can run, and then it enters the right Wi-Fi passwords, and then you see that it is connected. So it's a long one. I still need to edit this one, so I think I'm gonna call it here. Next time we're gonna make a TCP connection, and then we need to initialize the MQTT. Then we need to research sending something through MQTT, receiving through MQTT. And yeah, in general, we need to deal with how to communicate between tasks, because that's kind of a thing. And we'll be following a similar approach with channels like I did in the RC car. But that will be, I think, a little bit smoother, because I kind of know what I'm doing there. I tended to copy paste, and it kind of shows, but it's good to do this from time to time, so you just get a little bit more familiar. But yeah, it's late, I'm tired, so I'll continue next time. Have a good one, see you soon, and let me know what you're working on. If you have any questions, please leave me a like, subscribe to the channel, the usual. Well, take care.